The first problem is an expected number problem, but since this is about what you're going to go to until you get something, that actually then is the formula that you don't know. That's not on the formula chart. That's what I mean. You're supposed to know it. It's not on the formula chart. If you know n, because it's binomial, then here's your expected value with this standard deviation. But if you're going until, then you're using the geometric expected, which is your 1 over p. Okay, so that's why that one's 1 over 0.11, which is 9.09. Now, by the way, is this a percent or people or what? These are about 9.09 blood donors, but you can't have 9.09 blood donors. So what is this? This is on average. Okay, so keep in mind that, this is 9.09 on average is what that is. Okay. Next, this was just a straight up, the order. Because you know that the 10th one is where the 0.11 occurs. And all the ones in front of it are the 0.89. So here's your work. And then, by the way, your answers are in percents, not decimals. This is an old key. So you have the first 9 are 0.89s, and then you have this 10th one is the 0.11. Now, you can put this into your calculator as a geometric PDF because it's just exactly in that 10th spot. And I want the 0.11 to occur in the 10th spot. Okay, and that gives you the same thing. Now, before I go any further, I was going to tell you that in tutorials this morning we kind of came up with a good way to remember if you are struggling with how to know if it's binomial versus how to know if it's geometric. Okay, so here's another little memory device that we kind of came up with. Because it seems with both of these you know something. If you know n, meaning they say, out of 5 that you check, or they say, out of the 150 people that gave blood. So you know how many you are checking. If you know n, then that is a binomial problem. Okay? But on those ones that they just say, how many are you going to go until, or what's the probability that the first one you get is here, then that is defining an order. So if you know the O, then it's geometric. If you know the order, how many you're going until this first one that occurs is at the 6th spot, or whatever. Okay? So maybe that's another memory device to help you catch the difference between those two things. Okay, so back to this. So number 3, what's the probability that exactly 2 of the first 20 have type B blood? So this is telling me that n is known. This is telling me that I know n, so therefore that's why this is a binomial problem. We want exactly 2, so that's just equaling 2, and that's your 20 choose 2, 11 to the second, 0.89 to 18. Okay? And again, that's 28.22%. Alright. Number 4 is another one where you know n. You are checking 10 blood donors, the first 10 blood donors. Okay? But this one is different from the one above because it's a sequence of event. I want several PDFs, binomial PDFs. And remember that, I have a little deficiency in my brain where I can't add and subtract, but it helps me to write this out. Because This section here is often one I gotta really think about. Where's my inclusion and where does my inclusion stop? Okay, so I like to kind of draw this out and then go, okay, let's see. It says I want at least 2, so okay, I want 2 and more and greater. Okay, so that's my personal tool to make sure I get, does the 2 go here, or what the end of the inclusion goes. Okay, so what you write, yes, go ahead. So then what you are writing is formula, because that has to be your work. So you're saying, let the type B blood donors be those that are greater than or equal to 2. And I don't know about you, but I don't want to have to write the formula for 2 and 3 and 4 and 5 all the way up to 10. So what you are allowed to do is write the first one in the sequence. So here is that formula for 10 choose 2, yada yada, plus dot dot dot, the last one in the sequence, which is your 10 choose 10. And then you go over to your calculator and do something different to easier to get your answer, okay? But the work is showing the formula in sequence. Okay, now, so what I do when I go say, okay, I gotta do this in the calculator an easier way, then I'm thinking, okay, do you remember that our calculator does not allow you to accumulate all the PDFs from a point up? So our calculator does not allow us to actually just accumulate the PDFs from 2 and the PDF from 3 and then all the way up to the PDF of 10. It doesn't allow us to connect all those together. It only will accumulate from 0. So our calculator can accumulate the 0 and the 1, and that's the binomial cumulative up to and including 1, because this is what I don't want. So if the calculator is accumulating what you don't want, that's when you are doing the 1 minus. Let me say that again. If the calculator is computing, okay, and if the calculator is accumulating this section that you do not want, that's when you do 1 minus. So here I'm doing the 1 minus the binomial CDF up to and including 1. So I'm taking off the 0 and the 1 so that I get 2 up to 10 is what's left. Okay. What do you think about that? Questions there? Yes. It's too complicated? Up 2 to 10? No. Oh, well. Okay. Well, so, alright, so first of all, you aren't memorizing that big equation because you have this as a guideline. Okay? And so what's happening though is this is pretty much a really booger bear to compute. I mean, this is what you are doing. This is what maybe even in college they make you do by hand. Okay? If you went and took it in college, I've had some of my students come back and say they don't use a calculator. And then some of them say, but I know how to use it, and they'll let me use it, but they don't teach it. But anyway, so this is that formula that you're following, and you have to show that as your work, but we have the gift of getting to let our calculator plop out the number for us. So it's not a matter of all you need to do is let the calculator plop it out. We have to show and demonstrate the other part. Sorry, that's just the way it is. Yep. Correct. you put here is always what you are taking off up to. So if I'm taking off up to 2, then I would put here 2 here. If I'm taking off the bottom up to 3s, 3 down. If I'm taking off 3 down, I put 3 here. Put what you are taking off here and below. Okay? All right. Next. Yes. Yes. Okay. Yes. It's okay. All right. People have to process it. Okay. See how patient I am? I'll just say, yes. Good. Okay. Number 5. So this is saying out of 150 blood donors. Okay, so hey, guess what? Out of 150. So boom, it is known that N is 150. Therefore, it's the binomial situation. And the binomial expected value, right here, the binomial expected and standard deviation. Expected is the same thing as what you expect on average. So see, there's the mean. So the mean and the expected are the same, because that's what you expect on average. And then here's the standard deviation. So the cool thing is that for number 5, you just straight up got 2 formulas to fill in. And so for number 5, we've got the 150 times 0.11. And then that tells you how many people you would expect to get on average. And with this standard deviation of people on average, that's the ones that have type B blood. People with type B blood, by the way. Now, let's see. So I want to, so that I can bridge you into number 6, because I'm going to do number 6 very, very detailed. Hey, let's pretend like we did the blood drive here at Aledo High School, and we had 150 people that came into the blood drive. Okay. So guess what? When 150 people come into the Aledo blood drive, according to the American Red Cross, we should get about 16 and a half of them having type B blood with this much variation. So this kind of gives us a guideline of what we expect whenever 150 people come to the Aledo blood drive. So, I draw this for you. And here's the problem. So number 6. So 16 and a half people with type B blood, and these are samples of 150, by the way, is what is expected. So that is what's going to happen on average. That's what is expected. And then you have your 3.832. So see, use the numbers from number 5. Mean of 16.5, standard deviation of 3.832. So number 5's answers are used for the normal model of number 6. Okay, so you got, so 150 people happen to come in at Aledo, but you know what? You were surprised because you got a really low number. So the question is, what is a low number? Maybe I got 7, and so I'm going, I wonder if just getting 7 is considered really weird, because I know there's some variation. But I'm supposed to get around 16 and a half, and say like I got 7, and so I was going, I wonder if that's really unusually low or not. So, I got a really low amount when they came in, when we did our 150 blood drive. I got something unusually low, but I need to know, is that considered weird? So according to our normal model, when you are outside of how many standard deviations do I kind of go, whoa, that's unusual. Outside of 2. So this is that limit location. So if we got a sample at the Aledo blood drive over here, then we would go, we only got this many type B blood donors, we would go, whoa, that's weird. Something's happening. Okay, so let's see how many that is. Let's see what kind of numbers are over here. Well, guess what? That's 2 standard deviations down from what was expected to happen. So the common sense way, I'm going to do this 2 ways. The common sense way is 16 and a half, because that's what's expected. Take away 2 standard deviations, and you end up at 8.9. So this number is 8.9. So if I'm getting less than 8.9, then I'm going, whoa, something is weird. Okay? Now, some of you guys are very formula driven. If you are one of the very formula driven people and you want to use a z-score formula, then what's the z-score? What is this location here? -2. 2 down, -2. How many people, if 16.5 is the average, with this standard deviation, guess what that solves to be? 8.9. So if you're formula driven, there's your way of doing that. But in this case, I'm more common sense. It makes more sense that way. Okay, so I want to kind of make sure we answered what it says here. How many type B blood donors would it take to convince you that the estimate that the Red Cross gave us is too high? Okay, so think about this. The Red Cross says, hey, in the whole country, there's 11% type B bloods. So when you have your blood drive today, expect to have somewhere around 16 and a half. And go, okay, but we got something way down here. We got 8 or less people. Or I could say, if I get 8.9 or less on average, that's critical. Why do I have to have on average there? Because 8.9 is not what just happens in one sample. 8.9 has to be an average of what happens over many samples. So if I got less than 8.9 on average, or I could maybe we should want to say this. If I get less than 8, I don't use the average word, and I would have to say like real possibilities. So if I got less, oh wait, actually it's 8 or less, because 8's included. So if I got 8 or less, then okay, then I would be alarmed. You know what I would say? I'd say, holy smokes. We just got, what I was thinking is, you talking out, no. I was thinking I wanted to say, holy crap on a cracker, because that's what Kitty says on Big Bang Theory. But anyway, so I thought, can I say holy crap on a cracker? But whenever I say the S and y'all think I'm saying something else, then crap on the cracker is much better. But anyway, so, so if I just got 8, then I would be going, whoa, hey, guess what? You may have 11% type B in the whole country, but in here, in Aledo, you know, we're much different than the norm. In Aledo, we got a lot less, we have less than 11% happening in Aledo, okay? All right, so that's that problem. Ta-da. So, one last thing, and that is what you are turning in with your quiz. Okay, listen up. So with your quiz 17, turn in your chapter 17 homework, part 1. Turn in your 12 days of statistics. Turn in your warm-up that is beautifully completed, that I unfortunately didn't stamp for you. And that's what you turn in with your quiz. So here we go.